Hey, welcome back everyone. In this video, we'll wrap up our discussion on Chapter 2 and talk about line charts and scatter diagrams. We will discuss some of the common visual relationships you can identify with scatter diagrams, and then briefly go over the Pareto principle and a Pareto chart. So let's get started. A line chart is a two-dimensional chart showing time on the horizontal axis and the variable of interest on our vertical axis. So in this example chart here, our variable interest is the total sales in dollars, and then the week number is our time variable. Line charts are used to display time series data, and if you recall in Chapter 1, time series data is a set of successive data points over time. So this can be helpful to see trends over time, and then as we can see in this chart, we have an upward trend in sales by week. So to construct a line chart, our first step is to identify the time series variable of interest. So here our variable of interest is the number of mobile homes sold. The next step is to construct the horizontal axis for time and then the vertical axis for our variable of interest. So here on the left-hand side here, we have a table of data that we're going to use to create this chart. The year is starting from 2008 up until 2017, and then below each year is the number of mobile homes sold. So in step 3, we can then plot the points on the graph and then connect them with straight lines. So we don't typically do this by hand though, we would use Excel to create this chart. Let's jump into scatter diagrams next. So a scatter diagram, or scatter plot as I typically call them, is a two-dimensional graph of plotted points in which the vertical axis represents the value of one quantitative variable and the horizontal axis represents the values of another quantitative variable. So let's note that both variables must be quantitative or numeric in nature. So how do we really decide which variable goes on which axis? So if we look at the y-axis here, this is our dependent variable. These are values that we think are a function of or are dependent on another variable. That other variable is our independent variable, which are the values that are thought to impact the values of the dependent variable. We'll use scatter plots in Chapter 14, but here we're going to focus more on how to create them and what they could be used for. So scatter plots help us see potential relationships between two quantitative variables. So as you can see here in charts A and B, these are linear in that when I plot my X and Y data points, I can imagine a diagonal line that crosses right through them. So in chart A, this is a positive linear relationship because as X increases, Y also increases. In chart B, this is a negative linear relationship because as X increases, Y then decreases. So in charts C and D, these are curved linear, but we really are not going to cover these too much in this course. And then finally, charts E and F, these display no relationship. So in other words, there's really no clear directional relationship between these dots. Now to construct our scatter plot, we want to identify our two variables of interest. So recall that they must be quantitative or numeric. So in step 2, we want to make sure we understand which one's our dependent variable, which is going to go on our y-axis, and then which one is our independent variable, which is going to go on our x-axis. So let's review another example scatter plot. So in this plot, we're showing the relationship between temperature and ice cream sales. We believe that ice cream sales are impacted or are dependent on the temperature. So in step 3, we want to make sure that our scales and our axis make sense. So you can see that we have temperature in Fahrenheit on our x-axis. This is our independent variable. So then our y-axis, we have ice cream sales in thousands. So in step 4, we take the actual data and plot the joint values in this x and y space. So for example, when the temperature is 80 degrees and getting warmer, ice cream sales is 59,000. So we put a dot at the intersection of 80 on the x-axis and 59 on the y-axis. So once we plot all of the dots, so we can see here, it looks like there's a positive linear relationship between temperature and ice cream sales. The last chart we're going to talk about is a Pareto chart. A Pareto chart is a special type of bar chart which we learned in the previous video. This is applying something called the Pareto principle. This is an 80-20 rule that's often used in quality control applications. So in this example here, a company has been tracking machine downtime and the minutes of downtime associated with each cause. Here, we're presenting the data with a Pareto chart. The table to the left here shows the reasons that our machine breaks down, such as broken belt, an electrical issue, maintenance, operator or human error, and then waiting on materials, and then a miscellaneous bucket. We're also tracking down the average number of minutes of downtime for each category. So once we plot the data, we're going to display the chart in descending order, so the reasons with the most amount of downtime appear first, and then it goes down from there. This way we can focus on fixing the biggest problems or the biggest impact, because typically we really don't have the time or resources to fix every single issue. It is more impactful for us to focus on waiting on material and maintenance issues versus addressing those electrical or broken belts. So in the textbook, the example Pareto charts don't show this orange line, but you do typically see this done in practice. This makes it easier to see the cumulative percentage of total minutes of downtime. In Excel, this can be done using a secondary y-axis and then a line chart. Well, that wraps up this video covering line charts, scatter plots, and Pareto charts, and that also wraps up our discussion on Chapter 2.